So let's look at problem number 9. In this problem, we have a function, let's call it g of theta, and g of theta equals 4 theta minus tangent theta, and on the interval 0, on the closed interval 0 to 2 pi. In other words, one rotation. And we want to find the critical number of g of theta. Again, we call the definition. We're looking at values of theta such that g prime is 0 or undefined. So first, let's find g prime. The derivative of 4 theta is 4. The derivative of the tangent is the secant squared. Okay, so once again, we have the first case, g prime equal 0. So g prime of theta equals 0. This will happen when the secant squared equals 4 or the secant itself equals plus or minus 2. Okay. Now, you may not recall what is the value of theta when the secant equals 2, but you definitely need to recall that the secant is the reciprocal of the cosine. So instead of looking at the secant, I can look at the cosine and say the cosine is equal plus or minus 1 over 2, the reciprocal. Now, that's easier to work with. Once again, we have two cases when we have a positive value and negative value. Okay, so we can look at the positive value first and say theta equals the inverse cosine of 1/2. Well, the cosine is positive on the right side of the circle in quad 1 and quad 4, and this is a cosine of a spatial angle, so we are looking at either 1/2 square root of 2 over 2 or square root of 3 over 2. And if you remember that the sine of pi over 6 is 1/2, then the cosine of pi over 3 has to be 1/2. So we're looking at theta equals pi over 3. This is in the first quadrant, and again positive in the fourth quadrant. That will be pi over 3, 2 pi minus pi over 3, or 5 pi over 3. Those of you who are not accustomed to speak the pi language, then in degrees, we are looking at 60 degrees of 360 minus 60, which is 300. And since 60 is pi over 3, 300 is 5 times 60, or 5 times pi over 3. Okay, so likewise, we are looking at theta, which is the inverse cosine of the negative value, and this will be in quad 2 and quad 3. Okay, the reference angle is still pi over 3 or 60 degrees. Well, the corresponding angle in quad 2 will be 180 minus 60, or 120, or 2 pi over 3. And 180 plus 60, which is 240, or 4 pi over 3. So this result produced 4 values. So far, we're good? Now, this is the case where the derivative equals 0. The second case is the derivative does not exist. Same where we did in the homework problem number 9. So where the derivative does not exist, we're looking at 4 minus secant squared. So it means that the secant squared does not exist, or the secant does not exist. And we're going to say that secant theta does not exist when what happened to the cosine? Equals 0. And the cosine equals 0 where? Pi over 2 and 3 pi over 2, right? 90 degrees and 270. So it will be pi over 2 and 3 pi over 2. So on the face of it, it appears that we have 6 solutions, right? We have 3 from the derivative, using the derivative, setting the derivative to equal 0, and 2 more setting the derivative to be undefined. However, if you look at Weber's sign, Weber's sign expects you to give only 4 solutions. So where is the contradiction? Are we wrong thinking that there are 6 solutions? Or maybe Weber's sign wrong telling us there are only 4 solutions? What do you think? The question is, how many solutions we have? Do we have 4 or do we have 6? Okay. Very good. Very, very good. The question was, how many solutions you have? 4 or 6? And Kelton tells us 4 solutions because the graph of the function is undefined when theta equals pi over 2 or 3 pi over 2, which is correct. Because if you look at the tangent has vertical asymptote whenever the cosine equals 0, right? The tangent sine over cosine. And the cosine equals 0 at pi over 2 and 3 pi over 2. So pi over 2 and 3 pi over 2 are not in the domain of the function to begin with. If it's not in the domain, then we are not going to look at critical points over there. Okay? If it's not in the part of the function, then it cannot be part of the solution. So we're going to say that, however, theta equals pi over 2 and 3 pi over 2, this set are not in the domain of our function. G of theta equals 4 theta minus tangent theta. So, therefore, we have only 4 solutions, and the critical numbers of G of theta are this set again. They want it in order, so it will be pi over 3, and then 2 pi over 3, and then 4 pi over 3, and finally 5 pi over 3.